You know, we're asking AI to solve some of humanity's biggest, gnarliest problems, but what if the way we're teaching them is, well, just completely inefficient? There's a new approach that aims to fix this, and it's all about teaching AI how to study its own successes. So how does it work? Let's break it down.
I mean, we are throwing the kitchen sink at these models. We're talking graduate-level math, really complex logical puzzles. We're essentially asking them to become master problem solvers on a level we've never seen before.
So I want you to imagine a student, right? A brilliant student. They tackle a super tough problem. They work through it, find the solution, and then they take all their notes and just run them through a shredder. All that valuable work, that whole thought process, just gone. It sounds kind of crazy, right? Incredibly wasteful.
Well, believe it or not, that's pretty much what happens with a lot of standard AI training methods. It's this huge hidden bottleneck that just burns through computational resources and, maybe more importantly, throws away these golden learning opportunities.
Okay, so let's step inside this wasteful AI classroom for a minute and really see how this process works. And, figure out where all that good stuff is getting lost.
The standard way of doing things is a technique called on-policy reinforcement learning. It's basically trial and error. The AI tries a problem, and if it gets the right answer, it gets a reward. Think of it like a digital pat on the back. Then it uses that little piece of feedback to make a tiny tweak to its strategy.
And here is that shredded notes method in action. The model gives a problem a shot. It gets a score. It makes one single, tiny update from that result. And then, poof, the entire chain of reasoning, the whole process it just went through, is tossed out. It's one-and-done learning, and it is just wildly inefficient.
The researchers who worked on this just hit the nail on the head. This method doesn't just waste a little bit of processing power, it squanders substantial resources. It's like finding a gold nugget and throwing it away after only glancing at it.
So, seeing this massive inefficiency, it naturally led to a really fundamental question. If we're going to start saving those notes, what actually makes an experience worth saving and studying?
Because here's the thing, right? It's not enough to just keep everything. That's like a student just hoarding every single doodle and scrap of paper. You've got to be selective. So, how does an AI figure out which of its past attempts are the golden notes that are actually worth reviewing? The investigation into this question actually turned up two huge clues for finding these high-value experiences. And it all started with looking at the type of problem itself.
And the first clue led to what you could call a Goldilocks zone. See, training on problems that were too easy didn't really help, and just grinding away on problems that were way too hard, that didn't help much either. The biggest jump in performance came from focusing right in the middle on medium difficulty problems, the ones the AI could solve, but, not every single time, the sweet spot. The second clue was a metric called entropy. Now, that might sound complicated, but in this case, you can just think of it as the AI's own confidence score. When an AI produces an answer with low entropy, it's basically saying, I was very, very certain about every step I took. High entropy, on the other hand, means it was doing a lot more guessing. And this is a huge insight. Even when you look at all the correct answers, the ones that were the most valuable for learning were the ones the AI generated with high confidence. A low-entropy correct solution isn't just a lucky guess. It's a sign of a solid, repeatable reasoning process, exactly the kind of thing the AI should be studying and trying to do again.
So, armed with these two clues, focus on medium difficulty problems and look for those low-entropy, high-confidence solutions. The researchers built a whole new framework. They call it ExGRPO, and you can really just think of it as a smart study system for an AI.
So here's how this smart study system works. First, instead of shredding the notes, the AI saves every successful attempt into something called a replay buffer. Simple enough. Then, it sorts all those successes by how hard the problem was. Now here's the clever part. It prioritizes that medium difficulty bucket, our Goldilocks zone. And from that specific group, it picks out the best of the best, the one solution that was generated with the highest confidence. And finally, it replays and masters these top-tier experiences over and over again. It's all about studying smarter, not just harder.
Okay, so the million-dollar question, does all this actually work? If you teach an AI to be a more strategic student, does it actually become a better reasoner? Well, the results are pretty amazing.
Compared to the old shred the notes method, ExGRPO boosted performance by an average of 7.6 points on brand new, difficult problems the model had never even seen before.
I mean, that's not just a tiny improvement. That's a massive leap in its ability to generalize.
But this next part might actually be the most important discovery of all. It's about stability. See, standard training can be so unforgiving that weaker models often just collapse. They make zero progress. ExGRPO completely changes that game. By letting the model replay its early lucky hits, it creates a stable learning signal that can turn what would have been a total failure into a real success story.
And the hard numbers, well, they tell the exact same story. You look at these super tough benchmarks for advanced math and reasoning, and the advantage is just crystal clear. The ExGRPO trained model consistently and significantly walks all over the standard method.
So what you're seeing here is way more than just a clever training hack. It's a fundamental shift in how we can teach AI to actually think. Let's zoom out for a second and talk about why this really matters.
The key takeaway is this. Just like for us, smart, selective practice is way better than just mindless repetition. The real secret here isn't just about reusing old experiences. It's about having a smart system for picking and replaying the right experiences. And that makes the whole training process more efficient, more robust, and at the end of the day, way more effective.
And that leaves us with a really fascinating thought to chew on. We've just seen how we can teach an AI to be a better student of its own thinking. So if it can learn this effectively, this efficiently, from its own curated highlight reel, what's the next great challenge it could reason its way through? The possibilities there are pretty exciting to think about.